Hello friends, welcome to Susan and John MathTube. In this video, we will learn about pedal equations. Before we start with pedal equation, we should be very good with the Cartesian system. In Cartesian system, first we draw two perpendicular lines and we call them the x-axis and y-axis, and the intersection will be called the origin or the point of reference. The aim is very simple. We have to give some representation for each and every point in the two dimension. And the trick is very simple. Suppose I want to give a representation for this particular coordinate. I will measure this length. Let's say this is like 5 unit. And then I measure this length, means parallel to the y-axis. And if it is like 2 unit, immediately it will be given a name 5, 2. But did you notice you're actually giving the length and breadth of a rectangle? And that is why the Cartesian system is also called the rectangular coordinate system. Come on, if you have a coordinate here or if you have a point here, immediately you are creating an invisible rectangle. Okay, let this be 2 and let this be 7. The coordinate will be 2, 7. And this time you just gave the breadth and the length of a rectangle. So in Cartesian coordinate system, every point will be represented by length, breadth or breadth, length. By the way, if you have a coordinate something like -3, 7, this negative is not included in the length. It is just orientation. Go to the left, go up, come down. So this negative will control, negative and positive will control the orientation. Okay, now comes the polar system. In polar system, we do not draw x-axis and y-axis. Instead, we will have a reference point and that is called the pole. And we have something called polar axis. The aim is still the same. We want to give a representation for points in the two dimension. Come on, there will be infinite number of points. And here what we do is we believe every point is a part of a circle. Can you see an invisible circle with center pole, and we mark the radius and also the angle from initial line. So the coordinate will be r, theta. Instead of our x, y, we get r, theta. Now you just imagine a hybrid system. We have the Cartesian system and I'm going to incorporate the polar system by choosing the positive x-axis as the initial line. So in Cartesian, the name of a coordinate will be x, y. But in polar, the name will be r, theta. But they are not exactly equal. You cannot say that x is equal to r and y equal to theta. So let's go for the relation. Come on, in Cartesian system, this is x, this is y. In polar system, this will be the radius of the circle. And of course, this is theta. And by simple trigonometric calculation, you will be able to understand r is nothing but x square plus y square. To apply Pythagoras theorem. Okay, once you are good with this, we are ready for the pedal. Okay, the first thing we are going to learn is conversion from Cartesian to pedal. So here we go. We have a Cartesian equation. When I say we have a Cartesian equation, you can imagine something like x square plus y is equal to 2. Or maybe y is equal to sin x. Or any curve that comes in your brain. Anyway, when I have a Cartesian equation, I can create a Cartesian graph. That means I will collect all the coordinate which will balance this equation. For example, 1, 1 or maybe root 2, 0. I will collect all the points which balance and I'll get x, y, x, y, x, y and I'll be able to create the graph. So once more, we are given a Cartesian equation and our objective is to convert it into pedal equation. By the way, the word pedal stands for foot. It has Latin origin. You can read about it. So basically the word pedal has a Latin origin and it means foot, something related to foot. Okay, I'll tell you how this is going to get related to foot. So we consider one random point on the curve and I'm going to create the tangent. You know, tangent is a line and you know that the gradient of the tangent is dy by dx. So I'm considering one random point and I created the tangent. So let's imagine this is the point. The next thing to do is you have to simplify the equation of the tangent to ax plus by plus c equal to 0. The tangent is a line and the tangent can be written as ax plus by plus c equal to 0. Now we calculate the pedal. Pedal means we are going to calculate the distance from, the pedal length. We are going to calculate the distance from origin to the foot of the tangent. Can you see? That is why the name pedal came. And of course, obviously, we are going to denote it by P. And the next thing I'm going to do is, I'm going to consider the straight distance from origin to the coordinate. That will be our R. Come on, can you see that radius and circle? So we have P and R. So once more, you will be given a Cartesian equation. The first thing to do is you write the equation of the tangent. You might remember from your high school, equation of tangent is y minus y equal to slope. Slope is dy by dx into x minus x. Simplify the equation into ax plus by plus c equal to 0 and find p. Do you remember the formula for p? P is the distance from origin to the line. It is given by mod c by root under a square plus b square. If you want the proof, you can look at your high school books. And r is given by x square plus y square under root, but I squared it. The last thing to do is delete x and y, connect p and r. That will be the pedal equation. Okay, now let's look at the graph. So look at this. The black curve is a Cartesian curve. And like I told you, at every point, I'm going to calculate two things. Can you see? At every point, we can see the orange tangent and we are calculating the pedal length, the distance between origin and the tangent. So that is the P and R. And can you see the new curve is created? I'll be back very soon with the next video in which we will learn how to convert Cartesian equation into pedal equation. So till then, my friends, bye.